Behold the cosmic tapestry, an infinite expanse adorned with the most eclectic array of entities. Their vastness knows no bounds, separated by expanses so colossal that even light in its swift elegance loses itself in these unfathomable depths. Consider this: a photon, born of our sun's fiery embrace, would require more than 4 years to merely brush against the nearest star, traverse the intergalactic chasms, and one would embark on a journey spanning millions of years. Yet, amidst this colossal expanse, comprehend that this immense odyssey merely constitutes a minuscule footstep upon the grand scale of the cosmos. The sheer enormity of this realization is mind-altering, challenging the boundaries of our imagination. So how infinite, beyond our wildest dreams, is the universe? The solar system, just a speck in our galaxy's tapestry of planetary systems, revolves around a single star and hosts 8 planets, accompanied by a celestial entourage of millions: asteroids, comets, and meteoroids. Neptune, the most distant known planet within our system, sits at about 30 astronomical units from the Sun, akin to roughly 4 light-years. Yet, within Neptune's orbit lies just a fraction of our expansive system. Enter far, far out, the farthest object discovered, lingering at a staggering 132 astronomical units away from the Sun, an equivalent of 18 light hours. Even this entity, barely discernible against the cosmic vastness, remains distant from the hypothetical Oort cloud. The Oort cloud, its inner limits around 2,000 astronomical units from our center, and potentially extending to a whopping 60,000 astronomical units, nearly a light year, defines our solar system's gravitational boundaries. Beyond this threshold lies the uncharted territory of interstellar space. As we venture forth, within a 20 light-year radius from the Sun, we encounter a diverse array of over 50 celestial luminaries. Among them reside the enigmatic brown dwarfs, their dim glow contrasting with the brilliance of well-known stars like Sirius, Procyon, or Altair. Some of these stars harbor their own planetary systems, offering celestial bodies that might foster the birth and evolution of life. Take, for instance, Gliese 832, positioned roughly 16.1 light-years away. Exoplanets, exceeding the count of any individual planet within our solar system, boast an average surface temperature of 253 Kelvin or 20 degrees Celsius. Remarkably, these exoplanets complete their orbit around their host star in just 36 Earth days. In the grand scheme of the cosmos, the distance, roughly 732 light-years away, seems relatively close. However, for a spacecraft journeying at a speed of 17 kilometers per second, reaching such an exoplanet would demand an astonishing 300,000 years. As of now, crafting an interstellar vessel capable of sustaining such an extensive voyage remains beyond our technological grasp. The solar system, in tandem with its celestial cohorts, resides within the Orion Arm, a segment nestled in the grandeur of the Milky Way galaxy. This colossal galaxy boasts around 400 billion stars, encircled by an astronomical estimation of over 1 trillion diverse exoplanets. The Milky Way spans a colossal diameter of approximately 100,000 light-years, adorned with a stellar halo expanding twice the girth of its central disk, measuring roughly 1,000 light-years thick. Yet, at the galaxy's heart lies a remarkable bulge, a swelling known as the galactic bulge, stretching about 3,000 light-years across. As a member of the local group, a cosmic tapestry comprising over 50 galaxies, the Milky Way stands tall in a vast structure expanding within a space roughly 10 million light-years in diameter. Among these cosmic behemoths, the Andromeda Galaxy and the Triangle Galaxy reign supreme, potentially harboring a total of 3 trillion solar units within their celestial congregation. Our Earth, a mere speck in this cosmic ballet, rests about 2.5 million light-years away from the Andromeda galaxy, making it our closest galactic neighbor, dwarfing other galaxies except for the diminutive dwarf galaxies in the vicinity. The local group, a congregation of galaxies we call home, is a component of the immense Virgo supercluster, a colossal structure encompassing over 30,000 galaxies spread across a cosmic domain spanning about 150 million light-years. This colossal assembly possesses a vast total mass, reaching a staggering 1 quadrillion solar masses, equivalent to approximately 1,000 Milky Way galaxies. The supercluster itself exhibits a flattened form, where roughly 60% of its constituents assemble into a sprawling thin sheet spanning about 10 million light-years. While this expanse appears immense, in the grand tapestry of the universe's large-scale structures, it registers as relatively compact. Venturing further out, we encounter the monumental Laniakea supercluster, a colossal expanse stretching about 500 to 20 million light-years across. Within Laniakea lie various galactic superclusters, including the Virgo supercluster and others, collectively exhibiting a mass surpassing 100 quadrillion times that of our Sun. At the heart of this cosmic arrangement dwells the Great Attractor, situated roughly 250 million light-years from Earth, drawing nearby cosmic entities towards its gravitational center. Directly observing it is an insurmountable challenge due to the obstruction by the plane of the Milky Way, rendering the Great Attractor's essence a profound enigma, a puzzle yet unsolved by nature. Laniakea forms an integral part of the universe's vast architecture, a complex interweaving of galactic filaments, cosmic walls, and colossal voids. Among these structures exist entities of unfathomable scale, such as the mighty Hercules Corona Borealis Great Wall, extending an astonishing distance of about 10 billion light-years, discovered in 2013. This superstructure, believed to be the largest component within the universe's grand design, likely houses millions of galaxies, an exact count of which eludes comprehension. The existence of such a behemoth challenges scientific understanding. According to current theories on the universe's evolution, the formation of such colossal clusters is deemed improbable. Yet this immense wall, beyond the scope of human imagination in its entirety, occupies but a fraction of the observable universe. As per current cosmological understanding, our universe continues its incessant expansion. This expansion's pace hinges on the gap between celestial objects. The farther an observed entity resides from the observer, the swifter the space between them widens. Remarkably, this spatial expansion isn't restricted by the speed of light. It's intrinsic to the very fabric of space. Consequently, at certain distances, objects can drift beyond mutual visibility. Observations of relic radiation unveil that the observable universe spans a spherical domain approximately 93 billion light-years in diameter. According to the tenets of relativity, our interactions and observations are confined to this space, termed a metagalaxy. This region could encompass the entirety of the universe, or merely a fragment thereof. Beyond the visible confines of outer space, there might exist unknown entities, termed extragalactic or intergalactic objects, elusive and frustratingly beyond our current capacity for scientific exploration. Regrettably, these structures remain inaccessible to our scientific inquiry. Yet anomalies on the fringes of the observable universe challenge our understanding. Some celestial bodies there exhibit peculiar motion, defying expectations from available data. These anomalies might signify the presence of immense structures beyond the metagalactic boundary, exerting gravitational influence on surrounding cosmic entities. The universe's structure beyond this boundary sparks numerous hypotheses, but most delve into the realm of the metaphysical. Some propose a vision where, beyond the universe, conventional notions of time, space, physical laws, and concepts like matter, substance, or energy lose their significance. Expanding upon this notion, some suggest that the metagalaxy could merely be a fragment of a far more intricate and colossal cosmic superstructure, one potentially beyond our cognitive grasp, situated in multidimensional space or governed by unknown physical principles. The metagalaxy, in this view, appears as a minor aspect or a partial reflection of this astonishing superstructure. Certain interpretations of the anthropic principle even speculate the existence of other worlds, unseen and beyond the visible universe. The hypothesis regarding fundamental constants, like the speed of light or charge, closely aligns with the concept of a multiverse, a realm depicted akin to a foam, comprising myriad bubbles separated by impenetrable barriers. Each bubble represents a distinct universe, existing in its own space, governed by unique physical laws, conceivably differing vastly from our familiar ones. Some hypotheses take a radical stance, questioning the objective reality of our world. These theories propose that our universe is a simulation, akin to a computer-generated virtual reality operating at an immensely advanced level. Such an idea intimates the existence of a superbeing or an immensely advanced civilization whose intentions and capabilities likely surpass our comprehension, rendering proof or disproof of these hypotheses nearly impossible. Undoubtedly, cosmic distances are immense, reaching a scale that stretches the bounds of imagination and instills a sense of awe and fear in modern humanity. They appear infinite, and our understanding hinges on the knowledge that our universe is currently in a state of expansion. If this expansion persists, a moment will arrive when cosmic entities vanish, each slipping beyond the event horizon, galaxies fading away first, followed by stars. Such a scenario would cast our world into an unfathomable, eternal darkness, but no one will ever see it again.